Hello friends, myself Rajendra Mahajan presenting my video on inverse Laplace transform. Let us find inverse Laplace of s plus 1 whole divided by s square multiplied by s square plus 1. As there are two factors in the denominator, the first one is s square and the second one is s square plus 1. It is a combination of two types of factors. The first one is a repeated factor and the second factor is a quadratic factor. And as it is proper fraction means the degree of numerator term is 1 and degree of denominator term is 4. 1 less than 4 means it is proper fraction. And as it is proper fraction, applying partial fraction technique. Therefore, we can rewrite s plus 1 whole divided by s square into s square plus 1 as, for that repeated factor, a way to write is a by s plus b by s square. And for quadratic, it is cs plus d divided by s square plus 1. Then, finding the LCM of these three terms, the LCM is s square into s square plus 1. We get, dividing by s to this term, we get s plus 1 is equal to a multiplied by, remaining terms are s into s square plus 1. Then when we divide by s square to this term, s square into s square plus 1, remaining terms are s square plus 1 only. Therefore, b multiplied by s square plus 1. Then next we divide by this s square plus 1 to this s square into s square plus 1 product. Remaining term is s square only. Therefore, it is cs plus d multiplied by s square. Then simplifying it, we get a into s cube as plus bs square plus b cs cube and plus ds square. Further simplification is collecting similar terms in one bracket. There are two terms of s cube. Therefore, combining them, we get a plus c into s cube. Then there are two terms of s square, this one and this one. Therefore, taking s square common, we get b plus d into s square. Only one term of s, as, and constant term only one, that is b. Then comparing two sides, coefficient of s cube on right hand side is a plus c and no term of s cube on left hand side, therefore its coefficient is 0. This gives you a is equal to minus c. Then coefficient of s square is b plus d and no term of s square on left, therefore its coefficient is 0. It implies b is equal to minus d. Then coefficient of s is a and the coefficient of s on left hand side is 1. It gives you a is equal to 1. Then the constant term on right hand side is b and constant term on left hand side is 1. Therefore, we get b is equal to 1. Substituting these values, we get therefore a is 1, b is 1, C is minus 1 and D is minus B minus 1. A1, B1, C minus 1, D minus 1. Substituting these values in equation 1, that equation 1 becomes s plus 1 divided by s square into s square plus 1 is equal to A is 1 divided by s, B is 1 by s square, C is minus 1, s plus D, D is minus 1 and whole divided by s square plus 1. Then taking inverse on both, inverse Laplace of s plus 1 whole divided by s square multiplied by s square plus 1 is equal to inverse of individual inverse, taking individual inverse, inverse of first term 1 by s plus inverse Laplace of 1 by s square minus we can take common inverse Laplace of s divided by s square plus 1 and plus 1 divided by s square plus 1. Inverse of left hand side is some f of t. Inverse of 1 by s is 1, standard result. Inverse of 1 by s square is again a standard result, t, minus inverse of s upon s square plus 1, standard result, cos at, a is 1, means it is cos t, and inverse of 1 upon s square plus 1 is sin at, a is 1, therefore sin t. Is the required inverse Laplace transform or required answer? One more I will discuss in my next video. Therefore, please like my video, share it, as well as subscribe to my channel. And to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.